Hey, good evening, good afternoon, good morning. My name is Jordan Pinto, and welcome to my channel where we talk about technology, how the tiniest and basic stuffs work, the basic devices like phones and all those stuffs, how they work in their zeros and ones. Yeah. So today we'll be talking about the Arithmetic and Logic Unit. Most of you know about it. The tech enthusiasts, they know about it. If you don't know about it, I'll just explain it to you. So the computer or phone you use basically has something like a brain, and inside the brain there are two parts of it, which is the control unit and the Arithmetic and Logic Unit. The control unit basically is like the boss, it works hand in hand with the Arithmetic and Logic Unit, but the control unit basically behaves like the thinker. It gives the instructions for the Arithmetic and Logic Unit to follow. And what's the Arithmetic and Logic Unit? It's just a basic circuit. It's not a basic circuit, it's a complex circuit built with lots of logic gates, and its basic function is to do calculations. The calculations your PC does is done inside the Arithmetic and Logic Unit. So without talking too much, let's just go diving into what we'll be talking about today. So we are talking about the Arithmetic and Logic Unit, and this is a basic design of the Arithmetic and Logic Unit. As you can see, the keys here basically tells what it does. It does an addition, it does a subtraction, it does a multiplication and division. Today we'll be talking about the division, the multiplication and addition it does here. So this is how it behaves. This part of the unit does the addition. Most of you who do logic circuits and who understand about logic circuits will know that this is a full adder circuit, and this part basically is kind of a control for whatever that is being outputted. So this is a multiplexer, and it selects one of the inputs and displays it as an output. The decoder here, on the other hand, it behaves like a switch in this circuit. So what it does is that you can see numbers assigned to it, which is binary numbers assigned to it. So whenever you insert one of these switches on it, it selects one of the outputs labeled out here, probably a division, multiplication, subtraction, or an addition. I forgot to type it up here, but this is an addition. So it selects one of these outputs and displays it out here. So as you can see, it is selecting the 1 0, which is the multiplication. It's selecting it and outputting it here. So yes, how does this Arithmetic and Logic Unit perform an addition? So in binary numbers, adding numbers is quite straightforward, like how we do in decimals. You see, you just add 1 to 1, you get a 2. But in binary numbers, we count. There are two possibilities of the gates you can see in a binary number, which is probably ones and zeros as an on or off state. So here, what it does is that depending on the input you put into this side, it takes an input, add it to the second input, then transfers it to the multiplexer. If the port for its output is selected, it means it will be displayed here. So what happens here is that if you know about logic circuits, about full adder and half adder circuits, a half adder basically takes an input, two inputs, and performs an addition, proposes an output, or gives out an output with a carry. You see, like in basic normal in decimal calculations, additions, you can do a calculation where the number exceeds the base, as in you are calculating 9 plus 1, right? instead of you getting a 10, you are calculating 9 plus 1 here, you get a 10. Instead of you writing a 10, you write the last number, which is the 0, then you take the 1 to the other side. So that's what a half adder does. It takes the other unit and displays it, place it at one side, then the actual calculation is done on this side. Okay, so this is what happens. I want to do a calculating a 1 and a 1. Yeah, it takes 1, right? You can see it has selected its basic connectors and is going to wherever it should go to. So I selected the 1. Right now it's just doing a calculation with the 1 and zeros and zeros. Yeah, so I selected 1. If I do another 1 here, it means it's adding 1 and 1, and in 1 and 1 in binary you get 1 0. So the carry for this 1 and 1 is here. This is it. You can see a 1 here, and the actual value for the ones in the binary, like you see in decimal we have zeros, in the place value units you can see we have zeros, tens, hundreds, and this. But in binary we also have that type, but in binary we count in 2 raised to the power n. So we have zeros, we have the 2s, we have 4s, we have 8, we have 16s. So here instead of it it takes we've done a 1 and a 1 calculation here, so it's basically we'll get a 10, which is a 2 in decimal. So we get a 1 0. The 0 is the ones here, so the 0 should go here, and if we should select it here, we select it with a 0 0. So I'm doing that right now, and I selected it. So that's what it's selecting right now. Let me close this. You can see it has selected it has selected the addition port. So what's happening here is that it takes this one, it's doing a calculation with a 0. You won't get any number that exceeds the base, so it's still 1 is less than the base, so it takes the 1 and the 1 becomes a 1 once inside the base. So inside the output, so it just displays the output. But as soon as we add another 1, it now is equal to the base, so we get a 1 and a 0. The 0 is what is going out here. Because it's a 0, it means this gate is off now, so you won't see an output, but you will see a 0 here telling you that it's 0. But the carry, which is a 1, is being displayed here. So this is how a basic addition does here. The arithmetic and logic unit does a basic addition. So with subtraction here, I don't know how to go about it, but let me tell you how it does it in layman terms here. If I should build a subtraction circuit here, it will take time, but I'm explaining it to you. In binary numbers, we do subtractions using procedures, and these procedures we can use the first procedure we use in doing other subtractions is called the sign magnitude, where we assign a 0 or 1. We assign a 0 or 1 to the first side, or let me say this, the right side of the left side of the binary number. So let's say we want to know whether this number, the number 2, which is 10, is is a positive. We take 1 bit and add it to the 2-bit number, then we add 4. So the 1 bit you took now becomes the sign. When the number is 0, it means the number you have is a positive. But when the sign is 1, it means it's negative. So in layman terms, that is how the computer differentiates between the positive and negative. But this has a problem. The problem with a sign magnitude is that these calculations are inaccurate. You would understand that if you learn more about logic gates and how to represent sign numbers in this. So the best approach now is another approach in determining what the number or converting the decimal number which is a negative into a binary that will also determine that it's a negative. It is using the ones complement. That way, what you do is that you take the sign magnitude here, then now you complement every bit in it. So if it's a 0, it becomes a 1. If it's a 1, it becomes a 0. And this way too also has its problem, because doing calculations with it becomes a problem. So now the next or the best approach now is using the 2's complement. The 2's complement is, now you take the 1's complement, then you add 1 to the right side of it, which changes the orientation or the number. Now it's still the same number in decimal, but now it doesn't look like the same number when you just do it without the sign. So now you have the 2's complement, and now it becomes the 2's complement now is the negative value for that number. And what the arithmetic and logic unit does with this number is that subtraction is kind of funny here. It doesn't do subtraction like us and it takes one and subtracts the other from it. It's basically do subtraction by adding the 2 numbers to it. So this is where the negative number comes into play. So the negative number here now is a negative number, but in binary it doesn't look, there's no sign to show that it's a negative. The only thing you can see to show that it's a negative is when you reverse all the procedures you took. Then now you can see that now this is a negative or positive number. So now the binary digits look like they are positives, but one is negative. So what the arithmetic and logic unit does now is that it just adds the two of them, the 2 numbers together, and what you get is the results of your answer. You convert it to decimal, you get a negative if the first number is less than the second. If the first number is greater than the second, you still get a positive. So that is in layman terms how the arithmetic and logic unit does the subtraction. So in multiplication, on the other hand, now we are talking about multiplication, and the multiplication is basically adding and multiplying a number by another number. But doing a complex circuit about multiplication will be kind of tough. So this is a layman explanation of how multiplication works here. So a multiplication is just, you see, adding a 1 and multiplying a 1 by a 0, you get a 0. You multiply 1 by 1, you get a 1. So this is what we do. I used an AND gate to represent the multiplication, because AND always output a 1 when both numbers are 1, right? You can see now this line is on because both numbers are 1. As soon as 1 is 1 and 1 is 0, it means it multiplies this, and the output is what it gives here. So 1 times 0, you get a 0, which means this is off now. Let me turn the switch to multiplication, which is 1 and 0. Let us turn the switch for the multiplication. As soon as I turn everything becomes 1, you can see it has outputted. But now 1 and 0, you can see you have 1 and 0, you multiply, you get a 0, so nothing gets out. But as soon as you add a 1, it becomes 1 times 1 becomes equal to 1, so it outputs a 1, and you can see the 1 here. So that's it for my presentation. You will understand at the end now that the arithmetic and logic unit does addition by addition with negative positive numbers by just adding the 2 numbers together. So to get the negative number, you go through a procedure of first finding the sign magnitude, then now you convert it to a 1's complement, then now you convert it to a 2's complement to get the negative value of the decimal you want in binary. Then now you add the arithmetic and logic unit, which is the other circuit here. Now that's the addition for you. Then that's it. That's the subtraction. So in my next videos, I might probably do the subtraction part for you to understand how subtraction really works here. So that's it. Thank you for watching my video, and catch you on the next one.